Hello everyone. Today we are going to see about arithmetic operations using 8086 with MASM611 Simulation software. So in previous video, we have seen about the block diagrams of 8086 and what are the general purpose registers and how it is being used. In that aspect, we know that the general purpose registers can be used as a 16-bit register as well as an 8-bit register. So AX is going to be 16-bit and AH and AL are going to be two 8-bit registers. I can able to use it to make convenient so that the operations and other things can be done as an 16-bit as well as 8-bit operations. So in this aspect, while we are moving into the next values, so first arithmetic operation will be your unsigned addition. So if you want to see the syntax and other things of your unsigned addition, so add is going to be the addition of two numbers, so that the syntax which you are going to use will be add statement, and after that we will be using your destination and source. So first you will give your destination and after that you will be giving your source. So destination means the register or memory. It can be saved in a register, or I can able to give a memory location for it so that I can able to save that directly. And if it is going to be the source, it can be a register, it can be a memory, or it can able to hold the data also, immediate data. So while seeing in our lab program, we can able to understand little more on it. And after that, in terms of action, you can able to see that the destination is equal to destination plus source. It is going to do like this. If it is going to be add AL comma BL, which means like AL is equal to AL plus BL. So these are the flags which is getting affected. Unless otherwise there is a carry, we are not going to see about these flags. So that in unsigned addition, if it's and carry is going to come, at the time you are going to check your carry flag whether the carry has been occurred or not. Else we don't have to go for your checking of your flags. So this add statement can work for both your unsigned and signed up numbers also. And the next one is going to be your unsigned subtraction. So your syntax is going to be subtraction, and after that it is going to looking like similar to your addition operation. So the destination comma source. Destination can be register or a memory. Source can be register, memory, or immediate addressing mode, so that it can able to hold the directly the data, which is going to be the value which is going to be added or subtracted. So after that, in terms of action, it is going to be destination is equal to destination minus source, which is in subtraction. So these are the flags which will be getting affected. And this subtraction operation is also can work for statement can also be work for signed and unsigned numbers. And the next one is going to be your multiplication. So if you are going to use your multiplication, unsigned multiplication, so the syntax is MUL. So I can able to use it for both 8-bit as well as 16-bit operations. So previously also addition and subtraction can be used as 8-bit and 16-bit operations. So there will not be any change in terms of your 8-bit and 16-bit multiplication. But if you are going for addition, if you are going for your multiplication, we are having a small change over there, so that we have to be very careful in it. So if you are having your operand which is going to be in terms of 8-bit, it is going to give an 8-bit register or a memory, or it is going to take an 16-bit register or 16-bit memory. So in terms of action, you can able to see that if it is going to be your 8-bit operand, so that if you are going to say that MUL comma MUL in terms of if you want to say it as AL, so that you can able to simply say that MUL AL is going to do in terms of operations like, so the value of AL will be multiplied again with your AL and it will be saved inside your AX, like that we have to plan it. So if it is in terms of programming, I might have given with some other registers. So it is going to be saved inside your 16-bit register, even though if you are going to use your 8-bit register for your multiplication. So your expected output should be seen inside your 16-bit register AX. That is what we have to be very careful about. If it is going to be 16-bit, there is no problem. We can able to say that AX is equal to AX into the operand which is going to have in terms of 16-bit. It can be a memory location or it can be a register. But if you are going to use in 16-bit also, it is going to save in AX. If you are going to use your 8 bits also, it is going to save in AX. That is what you have to be very careful. And the next one is going to be your unsigned division. So in this unsigned division, your syntax is going to be div. So it can be used for 16-bit as well as 8-bit. So it can be a register or it can be a memory. So in this, the action if you are going to take in terms of 8-bit, so if you want to do it in terms of 8-bit operation in terms of unsigned numbers, so you can able to see that if you are going to do in terms of 8-bit, so if you are going to save the value in terms of 8-bit, so the 8-bit operand is going to be getting divided by the value of AX, and it will be saved inside your AL. So this is the thing which you have to be very careful about. So while you are doing our problems in terms of programs, we can able to understand more about it. If it is going to be your 16-bit operation, so it will be easy for us to have in terms of 16-bit operation, so that I can able to make use of the 16-bit operator itself, so that I can able to make use of it and I can able to divide it directly for my operation. So it will be very clear when you are moving into the program. So these are the syntax which is being used for today's video. So in this, if you want to move back, so this is your program, and this is the way how it is being calculated. A sample I have given for your understanding. So while you are going to see about this, so previously in previous video I have given an method, so that inside your DOS box you can able to use your edit command to write a program. But in other words, you can able to other types, you can able to go to your MASM folder inside your bin. You can able to create a document with respect to your notepad. So I can able to directly use my notepad document. So from that notepad document, I can able to save it as an .asm format. So I can able to directly use any of my notepad files. So and I can able to create a new file. So in this new file, I can able to type any program. After that, I want to save this program as .asm format instead of .txt format. I have to give it as sample or any of the program name, and I have to save it as .asm format, just like I have already saved in terms of my previous program. So like this also, I can able to directly open a program and I can able to start typing it. Instead of going to DOS box and typing the program, I can able to do like this also. So after this one, I have already typed the program and kept it ready for processing. So it is called as an 8-bit addition. So in order to have an 8-bit addition, so the value which is going to be taken here is going to be 11 and added with 22. So 11 is going to be represented in terms of 4-bit representations. It is going to be 0001, and 1 again it is going to be 0001. 2 is going to be 0010 and 0010. If you are going to add both the things together, it is going to give an hexadecimal value of 33, so that the equivalent binary representations can be shown here. This is how the operations are going to be handled by your 8086. So if you want to do that operation, to start with, again we will be having the same kind of setups, so that we have to declare the code segment, and after that you have to give a temporary name for your code segment. So to understand more, so you are going to start your program. So this move instruction is going to push the values of this hexadecimal values into this register, which is going to be AH. So this value 22 can be pushed inside your AL. So while you are seeing in your block diagram, you can able to see that AL and AH is being occupied by the two values, which is going to be 11 and 22, right? So this is immediate addressing mode, so that I can able to push the data directly into a register. So the data value has been given here itself. So I can able to see that clearly, and I can able to push it inside. So I can able to push the values, and after that I have to add both the things. So while you are seeing our PPT, we have seen about signed addition, right? Signed and unsigned addition, both the things are going to have the same syntax. Even for 8-bit as well as 16-bit, it is also going to be the same syntax. We can able to use it directly. So it should be having your destination and it should be having your source. That is what we have seen, right? So while we are taking this one, so add operator or instruction will be having its destination and its source, which means add the value of AH with AL and save it in AH. So this is your destination and this is your source. So the value is getting added, and it will be, we can able to see the values in AH. So which, and in terms of equation perspective, we can able to see like this: AH is equal to AH plus AL. So if I am going to add both the things, how I can able to visually see the thing? If I am going to see the value of AX, while I am seeing the register values, I can able to see the value of AX. So when I am going to do the operations, it is going to be first, it is AH is going to take the value of 1, 1. So it is going to take the value of 1, 1 here. And after that, the value of 2, 2 will be moved inside your AL. So this 2, 2 will be moved inside your AL. After adding both the things, this addition thing which is going to be happening after this one is going to move inside your AH. So 1122 has been converted into 3322. So after addition operation, it is being converted like this. So in the same way, I have done your subtraction, multiplication and division also together. So I have used the BX register in terms of two 8 bits. So it is going to be BH and the value of 66 is being moved inside. And after that, in terms of BL, value of 33 is being moved inside. So if I'm going to use it, so it is going to be subtraction BH comma BL, which is going to be a destination and is going to be your source. In this way, you can able to say that subtraction of BH with BL, and you are going to save it in BH. So BH is equal to BH minus BL. And if you are going to see that, so first initially the BH value is going to take the position, which is going to be here, it is going to be 66. And after the value of BL will be moved here. This is the value of your BX register. So this is the value of your AX register. And this is the value of your BX register. So it is case sensitive, so it's not case sensitive, so we don't have any problem in this one. So we can able to make it as BX. So first initially the value of is going to look like 66, and after that some garbage value will be there. After moving this 33, your BX register is going to look like 3333, and after that, if I am going to subtract both the things, again it is going to while it is going to look like 6633, and after subtraction of this BL values, it is going to be looking like 3333. So the BX value has to take the position of 3333. And in terms of multiplication, we can able to take some values and I can able to check how far it can be done. So it is going to be your moving the value of 44 inside your CL, and after that, in terms of this operation, we will not give destination and source, because the destination will be your AX register, and after that your source is going to be whatever values which you are going to give. So the value of 44 has been moved inside your CL register. So the value of 44 will be multiplied with your AX register, and after that it is going to save its value inside this AX register. Since I am using this conditions in terms of CL, so the multiplication things which is going to be happening, so this is going to be looking like AL multiplied by CL, and it is going to be saved in AX. It is exact meaning of this syntax. So multiplication of AL is done with CL, and after that it is going to save inside your AX. So already we are having an AX value which is going to be 3322, and after that if you are going to multiply with 44, if you are going to calculate with your hexadecimal operations, you can able to expect the value of 0908 inside this one. So here if you are going to see in specific, the value of AL is going to be 22, right? So the 22 will be multiplied with your 44. So if 22 is getting multiplied with your 44, and if it is going to be your hexadecimal values, so the multiplication is going to lead to 0908. So that I can able to see the values inside my AX register. So this is going to get the value of my inside my AX register. So after that it is going to be a division operation. So while I am seeing my division operation, so I can't able to do in terms of 8 bits. So I have to take AX directly. It will not be AL. Even if it is going to be your 8-bit division, it will directly do its division on its AX. So it is going to look like AX is equal to AX divided by DH, whatever value I am going to take here. So I am moving the value of 6666, which is going to be a 16-bit representation inside your AX register. And after that, I am going to move the value of 03 to the DH register, and I am trying to divide, and I am trying to understand the values, how it is going to be. So if I want to check it, so the value of AX, I can able to look it in terms of my 666 is divided by 3, so that you can able to expect the value of 2222 in terms of your AX. So these are the things which is going to be used here, so that I have to save as, and I have to give it as .asm format. So it will ask like already it's existing, whether I can able to save it, and after that I can able to give save, and I can able to save this operation. So I am doing the operation of multiplication, division, subtraction and addition in the same program, and I am going to see the register values to understand how this operation is being performed. So I can, after saving, I can able to close this file, and I can able to close this file also, so just for your understanding. So I can move directly into DOSBox. So after getting into DOSBox, I can able to type the syntax, and I can able to see it. So I can able to maximize it. So first we have to mount your C folder. So mount C is to MASM611. Okay, sorry, it should be C/, right? So it has been mounted. After that, we have to give it as C/, so that it is going to get its value of C drive. And after that, we have to move inside your bin folder, so that CD bin I have to give it. And after that, I have moved inside your bin folder. In that, I have given as experiment number 1 .asm. So okay, it should be edit. Sorry for this one. So I can able to use this one. So in order to open it, I have to use the command of edit. So I can able to open this one, and I can able to see whether the program has been got it here. Yeah. So whatever things I have done, it has been reached here from the notepad file in the name of .asm extension. So I can able to check it, and I can able to exit from this one. So after exiting, we know the standard procedures. So it is going to be MASM for execution of your program, MASM experiment number 1 .asm. So it has been assembled, so that I can able to create an obj file, and after that creation of obj file, I have to link that obj file. So experiment number 1 .obj. So after that, I have to press 4 enters, and after that I can able to reach here. After linking, I have to debug experiment number 1 .exe. So all these things we have already seen in our previous video. So while seeing this one, I might have asked you to check the values in terms of my u, so that we can able to say that the same program which I have typed, so the value of move inside my AH, the value of 11 is getting saved, and after that value of 22 is getting saved inside my AL register. All those things I can able to see. So previously we have used -G space the halt address. So in order we can able to see the final register values, but here I have to see the register values individually after every operation, so that it will make sense for my operations. So the command which we can able to use is T. So if you are going to use T, so the command which is going to be executed one by one, we can able to see those changes, and as well as the register value changes inside my register array. So -T, I can able to press enter. So I can able to see that first one is going to be AH,11, right? So in the AX register, in AH values, I got 11. So FF is garbage value. So till I have not changed those values, it will be having some garbage value. So it is going to have its FF. So after, if I want to see after the next execution of the next instruction, I can able to press T, and I can able to see. So the next instruction is movement of 22 inside your AL register. So while I am seeing my AX register, I can able to see that it is going to get the value of 1122. So next instruction is being executed, and after that I have to add both the things, right? So now I can able to see the value of AH has been changed to 33 and I am going to get the value of 22 inside my AL register. So I can able to see as a 16-bit register. So it is going to get the value of 3322. So after that one, I am going to move the value of 66 inside my BH. So that is being executed. And after that, movement of 33 inside my BL. So it has been done. So after that, I have to subtract it and I have to see whether the value of 3333 is getting at the other end. So you can able to see the BX register is going to get the value of 3333. So the subtraction operation is completed. So 8-bit subtraction operation is completed and I can able to save the values inside my BH register. So after that, I am going to change the value of your CL register. So I am going to get the value of 44. And after that, I am going to multiply with your values of AL, which is going to be 22. So 44 multiplied by 22. So we have expected the value of 0908 inside my AX register, right? So I can able to check. Yeah. So I can able to get the value of 0908 inside my AX register. So this is also done. So after that, next it is going to be a division operation. So I can able to see the 03 has been moved inside your DX. And after that, getting moved inside your DX register. So the values which is going to be getting saved. So it has to be divided with your AX register. So the AX register has been, the value has been changed. So that 0908 is divided by the value of 03 and we are going to get the values inside my AX register. So I can able to see these things and I can able to do the manipulation operations for 8-bit arithmetic operations. So you can able to extend the same for 16-bit operations by seeing the syntax of 16-bit operations in your 8086. So to quit out of this program, you can able to give Q and I can able to come out of this program. So press Alt Enter 2 times so that it will come out of this program. So I can able to close this one and I can able to see whether the thing has been specifically done using the program. So I will give the link for our instruction sets in the description. You can able to take the description link and you can able to open that file and you can able to check for 16-bit arithmetic operations, how it is going to work and how we can able to make use of that instructions for performing the arithmetic operations in 8086. Thank you for your patient listening.